We're now moving on to a little bit of a different dynamic and really focusing on the future outlook, what future endeavors lie ahead of us, and what opportunities lie ahead for humanity. It is now my pleasure to welcome Janine Benyus, established author and co-founder of the Biomimicry Insititute 3.8, and Corinne Ayozio, editor-in-chief of Popular Science, to share their thoughts and insights on the various ways biomimicry can help stem the tide of the COVID-19 pandemic and its devastating consequences. Through design and through looking into nature lies a million opportunities.
Thank you to the World Government Summit for that great introduction. My name is Corinne Ayozio. I'm the editor-in-chief of Popular Science, and I'm super thrilled to be here today to talk to Janine Benyus, the founder of Biomimicry 3.8. Janine, thank you for joining us. How are you?
I'm well. Be with you.
So I think the best place for us to start this conversation is to set some table stakes. Can you give us a working definition of what biomimicry means? I think if you tease apart the words, it might be self-explanatory, but there's certainly more going on here than we might realize.
Yes, bio means life. Mimic. So it's to mimic life. And what biomimicry is an innovation practice. So it's where biologists sit down with engineers and inventors, and they talk about life's best ideas. And then biomimicry is emulating those designs, those chemical recipes, those processes, those strategies, ecosystem strategies to make more sustainable products.
And so in terms of the disciplines of science involved here, it sounds like you touch pretty much everything, but clearly a lot of materials, right?
Yes, material science is really one of the most advanced parts of biomimicry. The way we make our world is pretty important. And so biomimics are looking at, for instance, during the pandemic, they're looking at how to keep bacteria and viruses from settling on surfaces. There's a company called Sharklet, and they've been able to mimic the textural pattern on a shark and put that on adhesive films on high-touch surfaces in hospitals, for instance, doorknobs and railings, and it repels bacteria rather than killing them, so it doesn't breed for resistance. With climate change, we're looking for ways that to take CO2 and turn that into materials. And life knows how to do that. Plants do that all the time. Coral reefs do that. So we have people doing biodegradable plastics using CO2 as a raw material. That's mimicking plants, and mimicking coral reefs by putting CO2 into concrete. Another example would be desalination. Mangroves are plants that can desalinate water, and they do this with membranes that have these special pores in them that move the water through. So people are now making membranes by those pores, doing osmosis instead of reverse osmosis, very low power, low cost desalination. There's all kinds of technical solutions, all the way up to the ways we design our cities.
So before we talk about the future design, and that is certainly something that I know we're going to touch on, I want to talk about how biomimicry can help us diagnose what has gone wrong. What are the natural systems, and what do they say about how a pandemic like COVID-19 can obviously it didn't just suddenly happen, but I'm sure that nature has some clues for us about where we went wrong.
Absolutely. I think what we realized is that planetary health is public health. We're realizing that the spillover from bats to people, that is happening more and more. 76% of our emerging diseases are zoonotic. They're coming from animals. And it happens when our developments, whether they be housing or agriculture or mining or cut, we move to habitats that these organisms have lived in for, in bats' cases, millions of years. We suddenly stress them and they begin to shed viruses. And that's how spillover happens. So it really makes us ask the question, how are we making our world, right? How can we do it without constantly looking for virgin materials and going and mining in wild places? Which brings us to, I think, one of the most important things we're going to be looking at in the coming decade is what's called the circular economy, where it's, recycling on steroids. It's really it's industrial recycling, where companies are literally sharing their byproducts with one another in a food web, in an industrial ecology. But products are not just landfilled, they're actually taken back and they're turned into new products. Biomimicry comes into play there because life is the original circular economy. The reason that life has such an ability to be able to upcycle its materials into, a log gets upcycled into bacteria and fungi that feed on that log. And then those materials get upcycled into mice, get upcycled into the hawk that eats the mouse, right? That's
so we're not
possible.
talking necessarily, sorry. So we're not talking necessarily about a closed loop, which is a little bit of a buzzword, right? We're not talking about an iPhone becomes another iPhone or a refrigerator becomes another refrigerator. We're talking about the materials, the component parts, and how they continue their life afterwards.
That's right. That's right. Because that's what happens. There's an upcycling cascade in the natural world. It's not a log becoming a tree. It's a log becoming lots of other things. And right. This is what's happening right now. What stops it from happening, frankly, is that we have so many different kinds of chemicals that we use. This is a very small subset of the periodic table. It uses about 6 elements and then, primarily, and then about 25 elements total. And we use the whole periodic table. Life uses that simple subset, adds design, adds structure to those materials, to those elements. And then when it comes time to reconfigure those elements into something else, there's a chemistry able to break that apart and turn it into something else. We need to mimic nature's chemistry textbook. And that's what's happening now with biomimetic chemistry.
So that's a great segue, because my next question was, how do we take these practices and encourage those with the means of production? How do we create systems that enable this type of thinking to happen?
Yeah, I mean, I think, for it's really important to have a research pipeline, because this kind of work, this biomimicry research, it entails having biologists who know enough about the sustainability issues that we have to be able to bring up the biological solutions at the moment of creation. We've created something at our nonprofit, the Biomimicry Institute. We've created something called Ask Nature to try to do this digitally, so that when designers or engineers or chemists sit down and they type in a function such as water repellency, the biological solutions will come up. They'll how ducks do, how leaves, and those are models, inspirational models, and actually engineering models to enable them to do more than just get inspiration from the natural world, but actually get the blueprints from the natural world. And that's what's necessary, especially as we move to things like 3D printing, new ways of manufacturing, additive manufacturing, where we can use a build file to add very intricate structures to common materials to give them the functionality that we want. So I think, funding this kind of research is going to be really, really important in the future, this kind of use-directed research, use-directed biology research. I mean,
right.
to give you an example.
So focusing as much on the application, yes.
Yeah. I mean, the way a biomimic thinks, and this is something that always makes people sort of gasp because it's so obvious when you talk about it. But with coronavirus, bats have been living for millions of years with high viral loads, and they do quite well. That is something we need to study. How is it that their immune systems do not react the way ours do and get super inflamed? And they've got different ways of dealing with viral loads, and they've done this for millions of years. So those are the sorts of research questions we need to be bringing young people into right now, with application in mind.
So probably the most tangible application, I know that your work has informed carpet design, and you mentioned concrete as an example, but how do we think about it in the really large scale, the large scale built environment, schools, parking facilities, office buildings, industrial campuses, right, that we need these places to exist to produce these things, right? To even have an idealized factory, you still have to build it, but how does it exist in an environment without creating more spillover opportunity?
Right, exactly. Well, the other thing about biodiversity as it relates to this pandemic is that we didn't have the full roster of species. And when we don't have the full predator and prey relationships going on, we also have more spillovers. So for instance, if you've got Lyme's disease, for instance, which is, there's a really good host, which is hooded mouse. Well, the red foxes used to prey on white-footed mice, but then coyote populations went sky high, and they eat the red foxes, and that's because we brought we took that apex predator of the wolf away that used to take care of the coyote. So what we now have is it's more than just being next to wildlands. It's making sure that those wildlands are healthy, that they have the full roster of species. So what we're doing now when we look at what does it take to make a biomimetic development, we're working a lot. We have something called Project Positive in our consultancy, where we're working with companies like Google and Microsoft and Ford that build factories and data centers. How do they build them in ways that actually contribute to ecosystem health? And that's called ecosystem services, when nature gives us these free carbon sequestration and habitat support and flood cooling the air and cleaning the air. Those ecosystem services have always been something that we consume. But what we're asking now is, can we produce them? So can you build a building and landscape in such a way as to store water, to sequester carbon, to actually support wildlife, whether it's in your green roof or whether you're doing habitexture where you're creating niches for hawks to nest. That idea that we take all of the ecosystem services mentioned in the Millennial Assessment and we say, how is the ecosystem next door, a relatively healthy ecosystem? We actually measure that. We get metrics. When you turn it into metrics, that's when engineers who are builders and planners are actually able to, hey, well, I have to store a certain amount of water. Maybe I need to make permeable pavement parking lots, or reduce my parking lots. Maybe I need to do awnings to have the building be able to shade and cool temperatures. Maybe by planting more trees, I take out pollutants and I help with asthma rates. which lowers the comorbidities next time there's a pandemic, right? So this idea is positive. It's to produce positive ecosystem services as we build. And it's thinking, but it literally is biomimicry at the systems level.
So basically, if in the footprint of the building, there are X amount of trees, and X amount of trees sequester a certain amount of carbon and convert as much carbon dioxide into fresh, breathable air, the building must then replace what those trees, what was in its footprint that is no longer tree.
Yeah, exactly. It's whatever system would be there, whether it's a prairie forest, depending on where you are in the world. We look at that, at the systems that are currently working, and we get a set of metrics and we try to meet them. So if you're doing carbon sequestration, you might plant trees. You might also use in your building, you might use CO2 sequestering concrete, biomimetic concrete. Right. You might use mass timbers. And together, your building and your site adds up to trying to match or even exceed the ecosystem services. So imagine a city that the water leaving it is cleaner than the water that comes in. And you say, oh, that's hard to imagine. It's not really, because that's what a forest does. So what we're saying is be as high performing as the forest next door. It's a new way of thinking, but we've watched it. We've watched companies like Ford adopt it now for all of their buildings in their Fordland sustainability strategy. I think it's the next natural thing after net zero. Once we reduce the harm that we're causing, how do we then go to positive? And creating it from place is a really powerful way to do it. And once you finish with your developments, you can start saying, well, how can we do agriculture in a way that stores more water, in a way that stores more carbon? What about the supply chain of the food that we're putting in our cafeteria? Can we also count the positive ecosystem services that come from us asking for a different management strategy on those lands, right? So it becomes this kind of project by project, a pixelated healing. And these are the kinds of large and radical moves that we as a species, I think, need to take post-pandemic if we're going to bounce forward instead of bouncing back.
Right. But that always comes back to the Monday morning question. What do we do about it? How do we create a world where this is a type of thinking that is actionable or incentivized?
Yeah, exactly. Incentivized is a good way of putting it, because I think, for instance, with that Project Positive, imagine if a city, as part of their sustainability vision and their climate change resilience vision, said, we want you to meet these ecosystem service goals per acre on your developments. That's a policy decision. It also can be a voluntary decision. For instance, companies can join Monday morning. You could join Positive at the biomimicry.net site, where a lot of, Kohler and Ford and Microsoft and Google and Interface and Aquafil, a lot of university campuses, corporate campuses. So join that, and then it's a learning cohort, and begin to make a plan that over the next 20 years, you're going to increase ecosystem provision from your landscapes and from your building sites. That's one thing. Another thing is to just see what the biomimicry community is doing in your country, because we've got 48 hubs. We've started biomimicry hubs where there are consultancies within your country, meaning you can bring biologists to the table. That's the Monday morning thing. It's where IDEO used to bring starting ergonomics people and psychologists to the design table. We're now bringing biologists. So find a biologist, hire a biologist for your next design endeavor. That's another way. We've got design challenges at the Institute. You can send, countries are sending teams of young entrepreneurs, basically, who are creating biomimetic solutions like Sharklet for important planetary challenges. So that way, send a design challenge team.
So the last thing that I want to talk about is going to jump back to something that you touched on, is this notion of planning. Because in terms of our supply chains, COVID showed all of the places where the chain is a little bit broken, and nature is so excellent at distributing resources and getting them where they need to go. What inspiration is there that a biomimic could point to for us to be able to get the things that need to be places where they need to be?
Yeah, you're right. The distribution networks in the natural world are not just effective, but they're now being studied for their strategies that we can mimic. So when you look at your blood vessels branching, your branching lung, your bronchia, or tree branches or roots, what you're seeing is a distribution network. And the imperative is to get nutrients or life-giving gases to every cell. And what that means is it's a fractal. You've got to actually get very small flows going at local regions, at local areas. So think small local banks, being able to get resources to local people. You also have, you've got small, medium, and large. You've got regional or mid-size flows happening in the natural world. Think ecosystems where you've got not just individual trees, but you've trees that are connected to one another. You've got large flows, distribution flows, and these are the oxygen cycle and the nitrogen cycle and the carbon cycle globally. All three of those scales are important. And when we lose local businesses and we move just to large businesses only, we get a lot of efficiencies, but we lose that distribution ability. So now economists, there's people at the Capital Institute, for instance, doing regenerative economies, and they're suggesting that we actually look at, do we have the full complement of scales? Have we, for instance, created too many regional banks, right? And left the little banks behind. How do we make sure we've got those distribution networks? And of course, this idea of, I think that's going to be very, very important, is local distributed manufacturing, in the same way distributed energy that we're looking at, distributed water treatment. Right. Distributed manufacturing, if it's safe, you could have additive manufacturing locally using local raw materials. It's not going to take away global flows. I think they're still going to be important in an industrial ecology. But we've realized that we need self-sufficiency for resilience, yes, and we need the large flows for efficiency.
Yes, you need there's certainly many, many lessons. I'm sure we could talk for another hour or two without even stretching the possibilities here. But I think that there's some excellent lessons that we've already started to crack open, where we can take the lessons from biomimicry and help move ourselves forward to a shiny, better future. Thank you so much, Janine, for talking with us today. It's been really enlightening.
Thank you. Thank you for having me, and the Government Summit as well. Enjoyed it.
Thank you, Janine and Corinne, for such an interesting conversation.